Struggling to manage a sprawling wireless network with hundreds of access points? What if you could centralize control, optimize performance, and scale effortlessly? In this video, I'll show you how WLAN controllers, WLC and Cisco AP modes can transform your network. From unified deployments to cloud-based solutions, discover the best architecture for your needs and learn how to leverage modes like FlexConnect and Sniffer for maximum efficiency. Ready to take your wireless network to the next level? Let's dive in. In this course, we'll compare several different WLAN controller architectures. That is to say, the WLC box. Imagine you want to deploy a WLC to support multiple LAP APs in your network. Where should you put the Wi-Fi controller? This concept, which is called the split MAC concept, can be applied to several different network architectures. On the diagram, we see 4 access points. Then your network can have a lot more, that is to say, thousands of APs. Scalability then becomes a very important factor in network design, especially when it's centralized. The WLAN controller can be located in several different locations. He can, for example, to place themselves in a unified deployment. A unified WLAN controller can typically support a maximum of 6,000 AP. If you need plus APs you will simply have to put a second one. A WLAN controller can also locate it in a data center, more known as a cloud-based WLC deployment. In this case, the device exists as a virtual machine. If the network architecture already contains a cloud computing platform, then its deployment will be simplified. A WLAN controller can typically support up to 3,000 access points. And as with a unified deployment, if the network evolves beyond that, then all you have to do is add new virtual machines. For small businesses, the controller can be integrated in a stack of switches. This process is called the integrated WLAN controller, because the controller is integrated into the device that switches the packets. Here, the maximum AP is 200. This limit can be increased by embedding new controllers on another stack of switches in the enterprise. And the last location of a WLAN controller is in an express mobile deployment, which is rather reserved for small structures. Instead of investing in a dedicated WLAN controller, it is possible that this function can be located directly on the access point. This type of configuration can support up to 100 access points. Deployment mode and utility. Unified for large company. Cloud for private cloud. Embedded for small company. Mobility Express for small site. Now let's take a look at the different modes that Cisco access points have. The APs can work in standalone or light mode, depending on the image that is loaded and launched into the case. We will detail, from a WLAN controller, the different modes of operation of a light access point. There is the local mode, which is the light mode by default. It allows one or more BSSs to operate on a specific channel. During periods when it is not transmitting, the access point will scan the other channels to measure noise level, interference, or to discover malicious devices. We have the monitor mode. Here, the AP does not transmit at all. Just its receiver is activated and functions as a sensor in order to detect unauthorized APs. He can even locate them as well. FlexConnect mode allows an access point to locally switch traffic between an SSID and a VLAN if its CAPWAP tunnel to the WLAN controller is down. We have the Sniffer mode. Here, the access point will receive 802.11 traffic from other sources, a bit like a switch with a mirror port configuration. The traffic captured in Sniffer mode will then be transmitted to a PC on which a packet analyzer tool like Wireshark. There is the Rogue Detector mode, which dedicates an access point to the detection of duplicate MAC addresses. That is to say, it will take down the MAC addresses that appear on two networks. Bridge mode turns the access point into a dedicated bridge between two networks, widely used to connect two locations separated by a certain distance. Multiple access points in bridge mode can form a mesh topology. Then we have the Flex plus Bridge mode, which is a mix between the two modes we saw just before. The FlexConnect mode works on a mesh access point. And the last mode is the SE Connect mode. Here the access point uses its frequency radios on all wireless channels to look for interference. And that's it for the different Cisco access point modes. One last small note is that a light access point is configured by default in local mode. That is, it provides BSS and allows client devices to pair with wireless LANs. And as soon as the AP switches to another mode, then the local mode as well as the BSS will be disabled.